Okay, a very good morning to all. I'm sharing the QR code. So give the attendance and then we will start. Wait, where is the QR code? Okay. Give the QR code, we will start with. See, only 8 students are present. पता नहीं मैं किसके लिए क्लास कराती हूँ. Okay. Attendance done, more or less. So we can start, right? Okay. So I'm sharing my notes with you all. Okay. So today we will discuss Hayes Bridge. Okay. My voice is audible now? Clear now? My voice? Clear to everyone?
Yes, ma'am.
Okay. Thank you. Thank you, Pooja. Thanks, Ayushi. Okay, now let's start. So today we will discuss Hayes Bridge. So Hayes का picture clear है, सबके सामने है. Yeah. So this is Hayes Bridge. Okay. So yesterday we have completed Maxwell inductance, capacitance. Okay. Any problem? Consult this video again. Video is already uploaded. Today we will discuss Hayes Bridge. So in your syllabus also after Maxwell you are having Hayes Bridge. अच्छा. So हर एक डायग्राम में ये ध्यान रखना पड़ेगा कहाँ पे हम क्या I mean with the resistance are constant parts in case of bridges. Okay. जो हमारे जो 4 arms होगा उसमें रेजिस्टेंस तो होगा ही, दैट इज द कांस्टेंट पार्ट, पर हम कहाँ पे हमें इंडक्टेंस ऐड करना है, कहाँ पे कैपेसिटर ऐड करना है, वो थोड़ा प्रैक्टिस करना पड़ेगा क्योंकि हर एक ब्रिज का अलग अलग कॉन्फ़िगरेशन है, अलग अलग स्ट्रक्चर है. सो दिस इज इम्पोर्टेंट दैट यू शुड practice and you should remember in which bridges where we are adding capacitance, where we are adding inductance. It is important. Okay. Now come to the fact that is Hayes Bridge. Now first of all, Hayes Bridge, why it is used for, let me tell you that clear with you. Hayes Bridge are mainly used for determining self-inductance. Okay. So I'm writing self-inductance. Self-inductance, okay, of the circuit. So the bridge, this bridge is, you can say it's a advanced form of Maxwell bridge because yesterday's lecture we have done with we have discussed Maxwell bridge. So this bridge is the advanced form of the Maxwell bridge. So Maxwell bridge is only appropriate for measuring medium quality factor. So yesterday I have also discussed with you quality factor, right? In inductance, capacitance, we have discussed the quality factor. So that quality factor in Maxwell is of medium quality. So for measuring high quality factor, Hayes Bridge is used in this particular circuit. So first of all, it is used to measure self-inductance, and secondly, definitely we will get high quality factor. That means you can say high Q factor. This is we should get from this particular Hayes Bridge. Okay. So this is our main two mottos. In Hayes Bridge, you see here the connection now. What is the connection? If you follow the connection, you will see capacitor is connected in series with the resistance where, see, first of all, there are 4 arms, R1, R2, R3, R4. Okay. Next, capacitor is connected in series with resistance. See here, have you seen the connection? This is the connection with the resistance. Resistance here is variable. I think that is visible to you all. It is a variable resistance, and the voltage drop across the resistance and capacitance are varied. Okay, so we can vary the voltage drop. And in Maxwell bridge, you have seen Maxwell bridge. So I can show you Maxwell once. Maxwell, let me show you. See here in case of Maxwell, where is the capacitance connected? It is in parallel. Okay. So ऐसे compare करके पढ़ना, then it will be easier for you to understand. Maxwell में capacitor हमने parallel में लगाया था with the resistance. But in case of this Hayes bridge, you can see here the capacitance is connected in series. So the magnitude of the voltage that is passing through the resistance and capacitor is equal. Okay. So now let's come to the construction of the Hayes bridge. So you can see unknown inductor L1 is placed along the arm AB. देखो हमारा arm AB कौन सा है? This is my arm AB. This is A. This is A. This is B. Right? So along my arm AB, or you can say, you can write capital AB also, that doesn't harm. So see here, capital A I have connected this capital B. Okay. So L1 is the inductor that is placed in the arm AB along with the resistance R1. So here L1 inductor is unknown to us. Okay. It is placed here in this AB arm along with the resistance R1. This much is clear. Now this unknown inductor is compared with the standard capacitor C4 here, that is connected in this connected in series with R4 in this arm CD. This is my CD arm. Okay, CD. So the resistance R4 is connected in series with the capacitor C4. This is, as you can see from here, resistance R4 is connected in series with the capacitor C4. Now the other two non-inductive resistor, here also you have two pure resistive resistance, that is R3 and R2. So they are called non-inductive resistance. Okay, they are connected in the arm. This is R2 is connected in the arm AD, and this R3 is connected in arm BC. Okay, I think this much is clear to you all. The total connection where we have connected, and the arrow I have forgot to add here. The arrow will be like this. Okay, the arrow will be just like this. Some points the arrow are given. Okay, arrow are given. Sorry. Okay, so this is the connection. Moreover, you have to also see where the E1, E3 is connected. See, this area is E1. It's written here E1. This is E2. This is E3. This is E4, because this we will require while solving the equation. Okay. So up to this, any problem, any query from your side, you can tell me. Then you see here, the C4 and R4, that means this one, C4 and R4 are adjusted for making the bridge in balance condition. How? When the bridge is in balance condition, definitely no current will flow through the detector. And where it is connected? Detector is connected between the point B, between the point B and D respectively. This is the D point. Okay. So current is flowing through A and C. So the potential drop across the arm AD and CD, okay, are equal. Similarly, you can say the potential drop across the arm AB and BC are equal. So in this case, we can say AD is equal to the potential arm, okay, is equal to CD. And secondly, again, you can say AB. AB is equal to this, the potential across the arm AB and BC are equal. So these two conditions are important. Here. This is done. Now we need to definitely move on to the equation part now. Let us see. Wait. So I need to clear everything. Okay. Now, wait. Okay. So what we have to see, the connection part is, you understood? I hope so. Now our L1 is the unknown inductor. So I need to find out the L1, which is having resistance R1, right? And R2, R3, R4 are non-inductive resistance, and C4 is standard capacitor, right? So L1 I need to know, which is having the resistance R1. R2, R3, R4. These are, you can say, suppose I can say R3, R2, and R4. So these Three are the non-inductive, non-inductive resistance, and C4 is the standard capacitor. Okay, so it is the not variable. Keep in your mind. Standard capacitor. Okay, I'm not writing the full thing. Now at balance condition, what you will write if you're asked to do? What will happen during balance condition? So in balance condition, I am opening my whiteboard here because यहाँ पे नहीं लिख सकते. ठीक है, balance condition में देखो हम क्या लिख सकते हैं. If I say I can write now R1 just like the previous in Maxwell I will write. Okay, because for Z1 I can write wait, R1 plus J omega L1. Okay, if I do something wrong then tell me. This is one equation. For Z4 what you can write? For Z4 definitely C4 is in series with each other, so we have to write minus Z by omega C4. Okay, that will be equal to R2 R3. Okay, clear? Now here definitely you will try to now separate the real and imaginary part we obtain. So here it will become R1 R4 R1 R4 plus L1 by C4 L1 by C4 plus J omega L1 R4 minus J R1 divided by omega C4. Okay, omega C4, and then you can write that is equal to R2 C3 R2 R3. So I have done nothing. I have just opened the brackets here, and I have just now I need to separate the real and the imaginary term. So if I separate the real and imaginary term, then I will obtain R1 R4, that is plus L1 by C4, that will be equal to what? R2 R3. Okay, R2 R3. Next, and the imaginary part will be L1 equals to it will be minus R1 divided by omega square, omega, yes, omega divided by, yes, R4 C4. So this is my imaginary and the real part segregation. Okay, now I need to solve the equations. If I solve the equation, I'm going to the next page. Okay, after solving, somehow I think I will get L1 equals to, I will get something. That is, if you solve it, you will also get R2, R3, C4, and 1 plus omega square R4 square C4 square. Okay, and R1 you can get omega square C4 square R2 R3 R4 divided by 1 plus omega square R4 square C4 square. Okay, so this thing you will get. So L1 and R1 you got, right? And so what is the quality factor we can write? Q factor or quality factor, whatever. So quality factor is omega L1 divided by R1. So you just put the values of L1, R1 here, and you will get something like this, omega square C4 R4. Okay, as a coach, this thing, something like this you will get here. Now, you can see here, the equation of the unknown inductance and capacitance consists of the frequency term, right, omega. Okay, so thus for finding the value of unknown inductance, definitely the frequency of the supply must be known here in this case. Secondly, for high quality factor, I told you that we actually incorporate Hayes bridge. So, but in case of high quality factor, this frequency actually does not come into play. So we obtain the high quality factor, that is Q equal to 1 by omega square C4R4. Okay. Now, if you try to substitute this term, this 1 by omega square C4R4 Q in this particular formula, that is in this, suppose if I put this equation 1, then what you will get, I mean, you need to find the unknown inductance, right? So you can substitute this term as Q into this equation. So in the next page, I'm moving. I can write the after substituting the value of Q, the unknown inductance L1 will be how much it will, how it will look, R2, R3, C4 divided by 1 plus 1 by Q whole square. Okay. Just check it out whether I have written right or wrong. मैंने बस Q के वैल्यू को रिप्लेस किया है यहाँ पे L1 से और मैंने उसका स्क्वायरिंग कर दिया, ठीक है, 1 by Q whole square. So for the greater value of Q, the 1 by Q is neglected and hence the equation will become, in that case you will see, because I told you we need to find out your high quality factor. ठीक है, so for greater value of Q you can neglect this Q and we can directly write L1 equals to R2, R3 and C4. Okay, so this is my required equation. I mean, I need to find out the inductance, self-inductance L1 from here. So this is my self-inductance. Okay, so now let us move on to, this is done. Let us move on to the phasor diagram of phase bridge. That is important. So let me take you to the phasor diagram. Wait. Okay, so this is my phasor diagram. See it very carefully. This is important. See here. The phasor diagram of phase bridge is shown here in this figure. The magnitude and phase of E3 and E4 I told you equal, right? In that from the particular previous diagram, the potential difference between E3 and E4 equal, E1 is E2 equal. This I told you. So how they have drawn this particular diagram? See, note here, first of all, the magnitude and phase, that is E3 and E4 are equal and hence they will overlap each other. Okay, and when drawn on horizontal axis. So see, E3 is equal to E4 I have written, and let me show you how they are overlapping each other. And current I1 will flow through the purely BD. BD arm means which one? Look into this previous arm. Current I1, where is current I1? This is the current I1. Let me show you. Wait. Okay, this is the current I1 flowing. I1 is flowing through BD because this is I1 current. It will start from here. We will flow through BD when in balance condition. Okay, so with purely resistive arm BD and the current I1, again they have a potential. What is the potential here? I can write. Let me tell you. I can write now E3 is equals to E3 is equals to I3R3 because they are in the same phase. Because they are in the same phase, and definitely it is see where it is represented by the represented here by a horizontal axis. So you see here, first of all, try to draw this kind of triangle where you can find you are trying to first of all depict that where we can put E1 equal to E2 and E3 equal to E4. So first of all, draw this horizontal line, which is important. Okay, and then draw this kind of this structure. This is drawn. After that, form a triangle. Okay, form a 90-degree right angle triangle. This one, this thing. Okay. Now you can see here, this particular line is parallel to this particular line. And this is visible, I think, to you all. And this particular line is parallel to this particular line. Okay, so because of that, we have drawn the dotted structure to form it a curve. Now, here in case of this Hayes bridge, I have seen that the capacitor is connected in series with the resistance. Okay, so for the capacitor, for actually I square by omega C2, sorry, there's J by omega C2 actually. Because of the capacitor, I have drawn this particular angle, the down angle. This you can see here. if this total angle I can take 90 degree. Okay. So this particular I have drawn. And now from here you can see this particular line is parallel to this particular line. So this dotted structure I have drawn parallel to this particular line. So all the dotted lines I have drawn, it is parallel to some line. Okay, so don't get confused. So this particular line, dotted line, is also parallel to this line. Okay, so we have drawn. Now you see here the thing. So here I have taken I1, R1, and this is my I2. I2 is equals to I4, this you know, and this will be I2, I3. Okay, this is the basic, I mean the horizontal axis. And here you can see it is I2, I2, R4, I2, R4, and here E3 is equal to E4. That is equal to definitely I3, R3. Okay, that is equal to I3, R3. And here again, E1 is equal to E2. So here you can clearly write it is I1 omega L1, and here I told you I2 divided by omega C4 because the capacitor is in series with each other. Okay, and I mean the resistance is like this, capacitor is like this in this case, but this was not in case of Maxwell. So that is why in Maxwell, we haven't received such kind of phasor diagram in the negative direction. Okay, so you see here the current passes through the arm AB. So you visualize the diagram which I showed you, AB. Current AB, they have a potential drop of I1, R1, right? Which is same as phase I1. Again, the total voltage drop across the AB is determined by adding the voltage I1, R1 and omega I1, L1. Okay, so I told you because the frequency have been taken here. Again, the voltage drop across the arm AB and AD are equal, which I told you. In the first thing I told you that AB and AD is equal, potential drop. Okay, if these two are equal, that means E1 and E2 are equal in magnitude and phase, and hence they overlap each other just in this phasor diagram. Now the current I2 and E2 are again in the same phase as shown in this figure. So current I2 now flows along the arm CD. CD means in the particular previous diagram you see, and it produces what? I2, I4. Let me go to the particular diagram. See here. If you follow this diagram, wait, let me clear. If you see here, current I2, where is the current I2? Current I2, this is I2. This I2 is flowing through the arm CD. This I2 will flow through here also. Okay. And it produces I2R4, definitely voltage drop. And across the resistance, and what is the voltage drop across the capacitor C4? It will be I2. It will be I2 divided by omega C4. This is my voltage drop across the resistance R4. Okay. Sorry, voltage drop across the capacitor C4. And so the capacitor C4 actually lags by current 90 degree. Okay. So make it clear. First of all, I told that current passes through arm AB. Arm B मतलब ये है AB. ठीक है. AB के थ्रू क्या करंट पास कर रहा है I1. तो इसके अक्रॉस पोटेंशियल ड्रॉप कितना होगा I1 R1. Okay. I1 R1. Clear? Which is same as that of the phase I1. The total voltage drop across the arm AB, that will be by adding I1 R1 and omega I1 L1. Okay. अब देखो voltage drop across the arm AB. This is AB and AD. AD are equal. This I told you. And so it's overlap each other. Now come to voltage drop across resistance C4 R4, which I told you that C4 already lags by the current 90 degree. Okay. So voltage drop across resistance C4 and R4, it gives the total voltage drop across the arm CD, because this is the arm CD. Okay. Now the summation of the voltage E1 and E3 and E2 and E4 now gives total voltage drop E. Okay. So in this phasor diagram, only that has been shown. Let me clear it. Wait. Okay, so this thing I have shown here, and whatever I have just told you, and the resultant of this is this one. The resultant of everything, I mean the resultant, the sum of the voltages of E1 and E3 or E2, E4 is this one. This is the resultant voltage drop, that is E, capital E. Okay, so this is the thing that how they have drawn, and because the capacitor here lags by 90 degrees, so देखो यहाँ पे horizontal axis के negative पे we have to take a we have to draw the phasor. Okay, so there are advantages of phasor also. What are the advantages? It is important to know. Definitely. So Hayes bridge gives a simple expression for the unknown inductance. Okay, and I told you it has a very high quality factor. So suitable for the coil having the quality factor more or less greater the quality factor greater than obviously 10 ohm. ठीक है, it is suitable for such kind of coils. It gives a simple equation for the quality factor and Hayes bridge, and it is use a small value of resistance for determining the Q factor. Okay, next comes these are the derivations which I did for you. I have showed you comparing the everything. Okay, and last of all, see, we have last of all, if I clear everything, I got this kind of Q factor. Okay, don't worry, I will share this with you. And disadvantages are there. Advantage, disadvantages. The equation of L1 and R1 are complicated. So you can say the only disadvantage of this type of bridge is that it is not suitable for measurement of coil having quality factor less than 10 ohm, because I told you that quality factor of Hayes bridge is somehow it is greater, it has to be greater than 10 ohm. So definitely it cannot be used for measuring low Q factor. Okay. So it is one of the most big disadvantage of Hayes bridge. And quality factor, in if you want to learn the definition of quality factor, so it is a parameter which determines the relationship between you can say the stored energy and the energy dissipated in the circuit. Okay, so it's a basic quality factor definition. It's a parameter which determines the relationship between the stored energy and energy dissipated in the circuit. Okay, so this is all about Hayes bridge. Now we can move to our next bridge. So let me see what you have in the next bridge. Wait. Okay. Wait for a second. Wien bridge. Okay, our next topic is Wien bridge. Let us see that. Wien bridge, I won't be able to complete that much, but let us start. Okay. Wien bridge, let us come to the diagram first. This is the Wien bridge diagram you can see. And a very, actually in case of this bridges, you need to know where you are connecting what. That is important. See, so Wien bridge is used to measure unknown frequency. Till now we were learning self-inductance. Okay, Maxwell and Hayes both were used to measure the unknown inductance. Now it comes to frequency. Okay, so Wien bridge is used in AC circuit for determining the value of unknown frequency. This is important. Okay, so bridges, mainly Wien bridge is used to measure what frequency. So definitely the other parameters will change. Okay, we are measuring the frequency. Now you come here, frequency, or the bridge measures the frequency from near about 100 hertz. Okay, 100 hertz to 100 kilohertz. This is the measuring capability of this Wien's bridge. Okay. And the accuracy, this is the bridge measures this much frequency. And the accuracy of the bridges lies between, you can say, it is 0.1 to 0.5%. So this much accuracy it provides. This much accuracy it provides. Okay. And the bridge is used for various other applications. You can say capacitance, measurement, harmonic, distortion analyzer, but frequency measurement is one of the most important part of Wien's bridge. Now, Wien's bridge is very frequency sensitive, and so it is difficult to obtain the balance point in it, okay, because it's very, very sensitive. So the input supply voltage here is not purely sinusoidal, and they contain some amount of harmonics. Okay, harmonics you all know, distortion, harmonics and all. What are harmonics? Harmonics are various oscillations in the waveform, and due to presence of harmonics, what happened? The supply voltage, it disturbs the balance condition of the bridge. Okay, so harmonic affects that thing. So to overcome all this problem, we need to use your filters. So that is why the circuit of Wien's bridge you will find a bit complicated as compared to Hayes and Maxwell. Okay, so so because of those oscillations and harmonics, we have to use filter in this bridge, and filter connects in series with the null detector. You will find, see, every time you will find that the filters are connected how. So filters are important in case of Wien bridge, and that we have to check, okay, in Wien's bridge. So today I'm not going through so much to the Wien's bridge because I will discuss it by next class. Achha, one more thing which I want to tell you, let us see one more thing, that is which I have discussed with you just now with the Hayes bridge. The formula, let me wait. Yeah. See, in Hayes bridge, I did this thing. Okay. The one thing which I did is that there I took the capacitor as a negative thing, but you can also follow this particular formula and you can proceed. So in the notes which I will give you, I will follow this formula. Okay. I mean, 1 by j omega, and then just simply you need to, I mean, Z1 equal to Z4 equal to Z3 equal to Z2. This thing you have to done. You have to do. Then you have to compare the real and the imaginary part. There is a big difference which I did in the whiteboard and here, because I have taken their capacitance 90-degree lag. Okay, that reason. So otherwise you can also follow this one. This will also do. And see here, another thing, the capacitance, you have to find out the L1, and the L1 value you need to substitute here, and you will get something. So here also same thing, you have to find out the Q factor. But what I have find out the Q factor, that is also correct. This is also correct. This is, now this totally depends upon how you assume the things. Okay. Now this Q factor is also correct, and my method of finding out it is also correct. So any of the one you can follow. There is no harm. Okay. It's not that mine I did that is wrong and this is correct, or this is wrong, mine is correct. It's not that. You can follow any of the equations which you feel good. So I will, you will be getting this video in YouTube. You can check it down there also, and notes I will upload. So you can also check out from there also, both the things. Okay, as per your convenience. So this is all I want to say. And next advantage of Wien's bridge I will discuss in my next class. Okay. Okay. One more thing, if you have any query, you can ask, and I'm sharing the password again, QR code, because many students have came late. Tomorrow, one more announcement I need to do. Tomorrow, I will be taking your class from 9:50, because on the day 27th of May, classes couldn't happen due to the cyclone and bad weather condition. So tomorrow, just that class I will take tomorrow on same timing, just like Thursday. Thursday, my class timing was from 9:50. Just like same timing, tomorrow you will be also having class from 9:50. Okay. So please do join. I know it's Sunday, but yes, I need to compensate the class. That is why tomorrow we will again sit, and tomorrow we will discuss Wien bridge. Okay, Wiens, and next whatever we have, Schering, Anderson, Risotti. many bridges are not in your syllabus, so some bridges are there. So the bridges which are there, we will discuss. And those who came late, give your QR code attendance. Okay. And if you have given your QR code attendance, you may leave. And thank you so much for attending the class.
Thank you, ma'am.
Thank you.
Help with their long-term morbidity, mortality from COVID. But in regards to some of these other medications that we keep hearing about, things like ivermectin, hydroxychloroquine, tocilizumab, there really is not a lot of good data out there to suggest that they help in.
So I don't